Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Attend RSA Conference 2020, February 24th through 28th in San Francisco, California. Visit securityweekly.com/RSAC 2020 to sponsor an interview with us on site at the conference or register using our code to save $150. Well, this week we are a little bit heavy in the bugs and the threats because I thought there were some interesting ones, as well as we'll start off with a bug bounty program for those of you looking to make money off of this. And this is a bug bounty program from Microsoft covering their Xbox. So Xbox is now nicely documented about what's in scope and what's out of scope. And one of the reasons I wanted to focus on this is just more to use it as a reference to talk about threat modeling and quantifying risk, as we were just talking about at the tail end of our last segment. Because when you look at bug bounty programs, you can at least see what the price of a vulnerability is, whether it is anything from a small misconfiguration to something that can lead to an account takeover or an RCE. So just having numbers associated with that, money essentially, is always kind of interesting, I think.
Yeah, and I like the way they break this down, right? Because you can really see the priority of where they're making the investment, the bug bounty.
Yeah.
If this were Jeff Bezos's Xbox, you'd hit like the first top 4 categories based on what happened to his iPhone.
Absolutely. And the other thing I think here is, too, that one thing that stood out is here is a bug bounty program that actually has tampering called out as in scope, because unlike most other programs, this isn't just a purely software. There's some hardware in here. And the other thing, too, under the out-of-scope vulnerabilities, just as we were talking about Clint's presentation from AppSec Cali in the previous segment, where do you spend your time? And Matt, you had also glommed onto this, is that complexity of the bug classes, and what do we really care about versus what should we just acknowledge and move on. These out-of-scope vulnerabilities are pretty good examples and good ways to think about, do we really need to be fixing these bugs or addressing these bugs, or do they really have any security problem? And these are things like low impact CSRF or CSRF that you can use to log someone out of their account. That might be annoying, but it doesn't really have a strong security implication to it. Or even something like a cookie replay. Now, immediately you could think, well, if I can replay your cookie, that's pretty bad, because then I can just impersonate Jeff Bezos's Xbox. But you also have to step back a second and say, well, if you're able to compromise the cookie, you probably, exploited some other type of significant vuln, or the way to compromise the cookie requires something else that's far more significant that needs to be addressed than actual cookie replay. So good things for thought, I think, in terms of just looking at different bug bounty programs and how they're designed.
Well, I like the denial of service, which means your Xbox is not considered critical. So if it gets DOSed, who cares?
Absolutely. Moving on to the bugs now, I was kind of torn between which ones I want to hit, if I want to build up to the fun or start with the familiar. So I think I'll start with the familiar and build up to the fun. I pulled out another Magento bug. So we've talked about this in the past. And it of course appealed to me because it was some deserialization and path traversal bugs in here for this, but it's also an app that is dealing with transactions. So, we talked about this is basically e-commerce 101 type of app. One of the things I wanted to talk about here is that I was trying to actually dive into the code and go use my git foo, so to speak, to compare the different versions and look to see what commits were calling out, what was being fixed, to basically be able to see, oh, here's in the PHP code, here's a couple of good ways to learn about how they're fixing these problems. What I found was it's pretty easy to use the Git or GitHub web interface to bisect different branches, but it's not easy to find particular security patches or security content in commits. And I just kind of thought that as an observation that if you are building code, what does your DevOps organization's culture look like when they are fixing problems? Do they reference their bug bounty reports? Are they referencing internal, either the Git issues or Jira tickets that are resolving security problems? And are you at least documenting it in a way so that others can understand why decisions were being made, or also just learn from the mistakes of the past? So that was a bit of the tangent that I want to pull us onto, talking about Magento once again. I think
muted.
John. Yeah, you're muted, John. Let's see if we can some more insight from John as he speaks.
Test 1, 2.
One moment, please. You can tell we do this live. There we go.
the guys see me talking, but they cut to me. But sorry about that. What I was going to say is, what was I going to say? Yeah. So we've talked about this a little before. And what's interesting to me is on this one is, again, when it's a little different on I don't want to say an open source project, but when you're committing to something in public, open source or not, right? If you do this on GitHub, there's a good chance someone's going to see it within seconds. So do you actually call out and say, do we have fixed a security thing, or do you try to, keep the clothing on, so to speak? I don't know. I would lean towards the, actually being transparent, but I think that's really a little around what you're saying, Mike. I think that sort of really shows off the maturity and the confidence in your development team and your security team to actually say, look, we found something, we're fixing it, versus giving us that, what is sort of a fun game of going through the diffs and figuring out, okay, do we see something in this we would consider a security issue? I was just scribbling a note. I wonder if there's something there around, could you either create an ML model or something that, not to identify the security risks, but to identify the fixes of security issues in Git? That could be sort of a fun little project.
Yeah, and I think one of the things that's always interesting is that also just having known vulnerabilities as a reference for the other type of tooling you're working with or creating can often be informative, both to say, is your tooling for finding problems accurate? Does it work against either this particular bug class or protect against this particular scenario? If it does, great. If it doesn't, it may just be that this is something that falls on that complexity graph that we were talking about in the previous segment, that here is a type of vulnerability that we're not going to be able to rely on our tools and maybe bounties programs for, but we need some more focused pen testing. Or maybe there's something else that we can do that's a bit more reactive to, at least, since we can't prevent necessarily the compromise, maybe we can react to it or detect it very quickly. And again, to that point too, I was just going to mention, there's a lot of investment in just reversing the binary patches from Microsoft Patch Tuesday, in looking at some PHP code should ostensibly be a little bit easier just to see what text changed from one version to another. I just lost my energy trying to get down and pull out some of the particular items there. But what I did spend some other time on was reading a really nice write-up from Checkpoint, lots of good technical details, as they were diving into the Azure stack. So it's basically a way on top of Microsoft Azure to basically build your service, build your product in a template almost, so to speak. And what was interesting, they found a SSRF vulnerability as well as an RCE. And what was kind of interesting is that it's a nice article because you can sort of read through not only the technical details of what they're doing, but also a bit of their mentality, a bit of the way they're thinking through, oh, this looks interesting, let's play with it here. And I think what was one of the quotes? It was the there was a command line argument that accepted a named pipe. And they ask, well, what data is sent over this pipe? And how can we influence it, or what can we do to influence it? And that is just a great approach from pen testing, as much as it is from a threat modeling question, in the sense of what are we building and what could go wrong. And so for those reasons, I thought this article was pretty educational, pretty informative.
What I liked about this article is it gets into an overview of Azure Stack. If you want to understand the complexity of what these environments look like and what's going on, not only in the cloud, but in these solutions that are trying to bridge cloud and on-prem hybrid environments, this does a really great job of giving you an overview of all the different elements and pieces that make up Azure Stack, and then dissect a couple, very interesting vulnerabilities based on that. My guess is there's more in here, because if you look at all the complexity and all the interaction at these different layers, my guess is there's other stuff in here. It's just the researchers focused on a couple areas here in this article. But this gives you a really good overview of how complex these cloud-based systems are.
Yeah. The two things there. One is, it's to be as flexible and sort of architected out. Yeah, you have to have API after API after API, and I like the way it sort of walked through, as you're saying, Matt. Going from this system, then an API call to here, and then you go do something over here, and then eventually you'll get a response back. It's nice to see they put that much thought into the architecture behind it. I don't think it's too often you get to see sort of how these things are running behind the scenes like this. But then the other thought I had on this was, I thought that, we were just talking about bounties. I thought the payout on this was a little low.
Yeah, that's true. Because there is a remote code execution in here. I think it was like 5. Was it 5 or 20,000? I can't remember, because it was pretty low.
So maybe there was multiple, and then they hit them for 5 each. But I mean, if you're given $5K for an RCE, that's a little less than I'd expect from a company with such resources.
Yeah, and the Xbox RCEs are $20,000 for a critical, right? But on Azure Stack, it's worth 5. Just saying, same company.
Yeah, no, that's interesting, and that's also one of the things that struck me too. I was excited to see an SSRF that also supported IPv6, so you can scan some internal IPv6 if you want. So at least IPv6 is deployed somewhere. That's always good to know. But what I wanted to get to, the fun one of the fourth vuln to talk about this week, is an RCE. So another RCE, this one in OpenSMTPD. So basically the mail handler from the OpenBSD team. And there's a couple of reasons to talk about this one that I wanted to highlight. One, this is the type of RCE that is easily accessible to anyone that basically has a shell and a netcap and can read ASCII characters, because it really is a way to very sneakily take advantage of a mishandling an error condition in the way that the OpenSMTPD handles parsing of email addresses. In this case, a error in the local part of the address doesn't return a proper failure code. And consequently, an attacker can craft a address in such a way that they can sneak in either a semicolon or a space, and then essentially get shell execution, command execution from that. And so there is a link to, in this article, there's a link to the initial vulnerability write-up from Qualys, which again is really nicely done. Also, a great shout out to a subtle reference to war games that I appreciated, which also made me want to talk about it. But also wanted to highlight this because, yes, of course, if we say OpenBSD has that reputation for an emphasis on security and a reputation for security, and yet here is a vulnerability that can crop up there. So it's not so much to try to poke them in the eye. It's more to share with other teams that regardless of whether you're doing your security processes through people, the more eyes you have it, all bugs are shallow, so to speak, or you're using tooling, or you are in a high threat environment because OpenBSD wants to be targeted and people just want the bragging rights of popping it. Vulnerabilities may exist, so it's much more, or it's equally as much, how do you respond to them and how quickly can you get a fix rolled out as well.
Well, what I thought was interesting is a lot of people who are using older versions are susceptible to this based on when it was introduced. This is one of the few times you see this really interesting benefit of being on an old version of a library because the vulnerability was introduced, within the last year and a half or so.
I know that's always the worrisome road to go down, because for as much as we always extol stay up to date on patches, stay up to date on your software, there's often these unfortunate counter arguments that come up every once in a while that says, well, this older version was in fact secure.
Right. Yeah,
the fun thing for me on this one was, we went from talking about cloud and Azure to talking about SNMP, and this for me, good or bad, I put it into the category of my first reaction is usually going to be, wow, people still run that? And I know there's use cases for it, but I stopped running mail servers personally, I don't know, over a decade ago. So I know it's still in use by some people, but it's always interesting to see what's outside your purview, so to speak.
No, absolutely. And I think that we could, broaden that into also just that idea of threat models. Do you want to run your own SMTP server, or do you just want to let someone who's an expert handle that for you and deal with the SPF, DMARC, all the great stuff that actually takes care of spam and is much more friendly to users as well, let alone more friendly to servers being secured and managed? But what I want to do now, I think, is let's turn away from talking about just some individual bugs and what we can learn from them, and two other areas under food for thought. So one is in the spirit of threat modeling, wanted to highlight another article that was talking about Fintechs divided on screen scraping ban. Now, this is was focused on a discussion from Australia responding to legislation being discussed in regulations in the EU. But I also wanted to broaden it too from not just fintech and screen scraping, but screen scraping and bots in general, because we've also seen LinkedIn had a famous case about this, about trying to prevent screen scrapers. And then there's also Clearview that we mentioned just last week, we alluded to last week, about scraping social media sites and images to do facial recognition on people. And then just more generally, as an application or product security DevOps team or DevOps focused team, how do you start to defend against these types of bots that are either authentic or inauthentic types of activity against your site?
So let me give a little more precursor to this, because I think this is interesting, because Visa just bought Plaid is part of enabling connections into banks. One of the things Plaid uses in the background is a lot of screen scraping technology. That's how they actually make this product work. And so what you have is this really big acquisition. Visa paid $5.3 billion for Plaid that happens to use a lot of these screen scraping techniques we're talking about to enable people to get access to their banks and move money around. So this is more than just bots, I think, at the end of the day. There's actually some acquisitions happening that are using these same techniques that I think open up some really interesting questions.
You're right. And there's a lot of things to also unpack from there because if like a service like Plaid, or for example, Quicken is another one that comes to mind as well, you are giving that service your credentials to the third party, to the bank that's logging in so that Plaid or whatever other service can go and scrape the site. And so now we're talking about this having that service needing to secure those credentials, but also then training users to provide credentials as opposed to necessarily like OAuth assertions. And part of this, you could also look at the different banks not supporting an OAuth type model, and therefore now users are actually having to share their credentials with third parties in order to do this type of screen scraping. So there's a lot of interesting security and threat modeling we could do unpacking from this type of article.
Yeah, definitely.
And also, I mean, again, I think your original question there, Mike, sort of, I want folks to think about that a little bit. From the point of view of, we think about a threat model of like, I'm developing this product and how's someone going to attack it? Think about what's going on at some of these screen scraping guys. If especially, who's the big guys? Clearview. If I'm writing a product and one of my core ways of gathering information is to screen scrape off of, large sites like Facebook, which have fairly complex, mature security teams, I'm going to be spending a lot of time head scratching around how do I develop my screen scraping and how do I actually go about farming that data, right? You're not starting with A and going through to Z. You're going to do something a lot more random and try to spread out your IP addresses and use all sorts of different tricks to try and not wake the beast. So it's again, we're back to cat and mouse, obviously, but that's something to sort of think about is when you're thinking about doing that threat model of who is your attacker, who could your attacker be, and how would they go about gathering this information from you, and then how do you protect against that?
Right, and I think a lot of it can come too from, do you provide APIs that enable capabilities that are good for your users, or that are or support feature development that your users are asking for? And when you also have those APIs of course can be abused, but it's a lot easier to monitor APIs, rate limit. Well, I'll say a lot easier, relatively speaking, but the detectability against screen scraping is easier when you, in the sense of here is a actor using a single API key to try to pull down tons and tons of data, versus someone who's attempting to avoid detection or even evade blocking techniques that might be in place by running a bunch of Phantom JS headless browsers, or just running a Amazon Mechanical Turk, adopting something like that to do screen scraping as well. And so those purposes are, have highly different motivations and present different challenges for teams trying to protect their endpoints. And then the final article I wanted to talk about was a GitHub repo from the UK's National Cybersecurity Centre. And essentially they put together a reference for adopting a zero trust architecture. So zero trust obviously isn't something particularly new. It's been talked about by Google, is the most famous, the most vocal one. Precursor even to that was IBM was developing essentially what was zero trust at the time and describing that type of thing. And here, I just thought this was a great reference, and I wanted to highlight a subset of these, numbers 5 through 8, that I think are highlighted or are lean more towards the application security level. And these are about knowing the health of your devices and services, monitoring them, setting policies about access, and controlling access to them. And one of the things that we actually haven't, that just comes to my mind, is we've been talking, even in the last segment, about scaling application security and being so bug heavy in this particular segment, is that we haven't really talked about what happens when things go wrong, and what do you do with your product security incident response team, or how do you manage one, or how do you respond to bugs and bug reporting? And so I'm just going to set that up as a marker for one of our future topics. And we can still pull some information from Clint's presentation. So there's still a bunch of slides near the end there that can speak to this. But talking about zero trust leading to a application layer incident response, I think are all well tied together and things to think about for your DevOps team.
Yeah, we did a segment Thursday night on Paul's Security Weekly when I was in studio last week with Peter Smith from Edgewise, and we broke into this a little bit. When you look at most zero trust solutions out there, they're either at the network layer or at the identity layer. And what Edgewise does differently, and one of the unique things that this repository brings up as well, is software and applications play a role in here. And so by understanding not only what can communicate to what, but understanding those individual components or software and the identities associated with those is really the way to build out a true zero trust architecture. But a lot of people focus at the network layer or the identity layer, and they forget about the application software layer that is an important part of this, especially in these new architectures where we have a lot of microservices and other distributed components. To understand that and to be able to enforce that from a zero trust perspective is really important. So this breaks into it a little bit, but that segment we did last week also highlights a lot of this as well.
I think that's one of the interesting. I think that's one of the interesting things there. So you can pick something up off the shelf to do zero trust. But I think a really large portion of it is it's going to come down to what is the architecture of your application and your services, right? It's how you probably want to go fairly deep into your code, or at least relatively speaking, to be able to do this. At least I think, right? Can you trust a off the shelf? How much can you trust an off the shelf? I can't talk today. How much can you trust an off the shelf software package to help you really implement that? I mean, there was an article we had in the backlog talking about what Mongo has done. Again, that's an open source package, so it's a little different as there's a vendor, but I think someone off the shelf can help somewhat, but can they do it completely?
Well, they have to understand what's going on, and that was the interesting discussion about how they approach it. The segment started as Python backdoors and the ability to actually monitor Python and be able to eventually lock Python as a library down to prevent against some of these attacks. That's a very specific component. But then you broaden that into understanding all those different pieces of software, how they're communicating, and then applying a set of rules. And they say they can do it in like seven rules to protect an environment based on how they detect and monitor what's actually going on in your environment. Anyways, it was very interesting. We're going to bring them back for some more deep dives on some of these topics, but just an interesting concept and an additional component that the network and or the identity guys by themselves aren't using.
Yeah, and I think the only thing I can do is most basically, repeat what you said. Check out that that episode from last Thursday, and just emphasize too that number 8, controlling access to your services and data. That isn't just about these are developer access to production services. It's more about how are the services interacting with each other that you're building, and can you actually have service to service identity, and as well as access controls on the data that's within it, so that the data can be also quarantined as needed or access control restricted as needed. So again, high level, but good ways to start to frame the problem, and hopefully a resource that starts to build and becomes more useful as a reference. So with that, I think we've hit the end of this segment for the news. So I want to thank Matt and John again. I want to thank all of you for joining us. We'll see you next week on Application Security Weekly.